The wild, the great unknown, the untamed organic hinterland of nature, overrun with lush vegetation and undomesticated wildlife, blooming and bursting with life, but luckily untouched by human hands. Until now, there you are amidst the landscape of herbage and greenery. The calls of birds echo behind you, the trees dance peacefully, the turbulent wind rustling leaves remind you of the ebb and flow of calm ocean waves. Why are you here? You don't know. That doesn't matter. You're having a good time. That's what matters, man. After all, which great adventure started with the protagonist knowing where they were and how they got there? Come on, that's basic cliche story writing. Anyway, where even are you? Is this paradise? Explains why no one else is here. Or is it heaven? Pretty lonely for heaven. You begin to walk forward, trekking slowly beneath the understory and through the vegetative greenery of the forest floor. A rustling behind you snaps you out of your wide-eyed stupor. You turn around quickly, your eyes are swerving from one extreme of your vision to the next. Is it some sort of beast of the jungle? Is there some sort of monster in this paradise? Has God finally found you and decided to send you back into the world like a bag of popcorn that hasn't finished popping in the microwave? There goes the rustling again. What is it? You feel like it's coming forward towards you suddenly. The suspense is palpable. Are you gonna die? Does it matter? What is gonna... The beast rears its head from its underground hole right before you, twisting and writhing with its eyes closed. It's a mole, and it's barely the size of your forearm. What's a mole doing in the forest? You'd assume they're more common in grasslands and urban areas. Oh my gosh. You've been dreaming this whole time. Welcome back to your personal hell. Your class test on mole concept. There are 3 minutes left. You've got to stop blacking out in tests, man. The least you could have done was study. Even worse, your brain was so masochistic that it trapped you in a virtual paradise with the only thing that would not help you in this test for, 20 whole minutes. Better than staring at your paper you didn't understand, though. Or was it? Whatever, you've accomplished nothing, and now you await your impending death in 2 minutes now. Great. We'll check in on you later. Pretty scary alternate reality, eh? Well, this video definitely won't be 2 minutes long, but you'll definitely learn something by the end of it. You clicked on this video for mole concept, and you will get it, trust me, but first we have to cover everything that correlates to the mole. The first stepping stone in understanding mole concept is relative atomic mass. See, at some point in history, around the 1800s, chemists including John Dalton and Thomas Thomson, great name, decided to relate the masses of elements to one another. It wasn't until around the 1960s that physicists and chemists finally broke down and realized that they should probably just use the same scale of atomic mass. You see, relative atomic mass is the ratio of the mass of an atom of a certain element in relation to 1/12 the mass of a carbon-12 atom. Carbon-12 is the basis of this scale of measurement because it has an atomic mass of exactly 12 atomic mass units, or daltons. Wait, what? Let's just get rid of that one. Relative atomic mass is dimensionless and has no units. It's written like this, A with a little r next to it. How do you find relative atomic mass? You don't find it. Well, you can find it on Google, but otherwise you just kinda have to know common ones. CSEC will give you the relative atomic mass in questions that need it though, so you just have to know what it looks like and how to use it, as we'll discuss later on. Now on to relative molecular mass, which is basically the same thing, but we also use the ancient technique of addition. All you do is add the relative atomic masses of every atom in the molecule. So if we had a very obscure compound, you probably haven't heard of it before, it's pretty insider knowledge, DHMO, dihydrogen monoxide, pretty dangerous. Rumor has it the government puts it in most food and drink to track you. With the formula H2O, we simply add the relative atomic masses of the 2 hydrogen atoms and the 1 oxygen atom, leaving us with 2 times 1, the relative atomic mass of a hydrogen atom, plus 16, the relative atomic mass of an oxygen atom. So the relative molecular mass of water, DHMO, is 18. You see, when we talk about a mole, we mean a specific number of particles. Just like how a dozen always means 12 things, a pair always means 2, and flow internet always means 1 kilobyte per second, a mole refers to a definite number of particles. These particles can be atoms, ions, molecules, or even electrons. Stay tuned for an electrolysis video. Specifically, a mole is the amount of substance which contains as many particles as there are atoms in 12 grams of carbon-12. The number of carbon atoms in 12 grams of carbon-12, if you're wondering, is known as Avogadro's number, which is equal to the value of 6.023 times 10 to the power of 23. It can be rounded to just 6 times 10 to the power of 23 though, if you don't want to seem pretentious. Avogadro's number, written as L, is the number of particles in 1 mole of any substance. So 1 mole of carbon has the same number of carbon atoms as there are water molecules in 1 mole of water. Alright, you may be wondering what all these arbitrary dimensionless numbers mean and how they relate to mole concept. It's quite simple really. As a matter of fact, let me show you. The mass of one oxygen atom is 2.66 times 10 to the power of negative 23 grams. If you multiply that by Avogadro's number, go ahead, do it. You get a little more than 16 grams, which, if you can remember correctly, is the same value of the relative atomic mass of oxygen. When we multiplied the mass of one oxygen atom by Avogadro's number, we calculated the mass of 1 mole of oxygen atoms. This is known as the atom's molar mass, and yes, it is the same value as the relative atomic mass, and yes, it's basically just this number right here. The molar mass of a substance is written in grams per mole. Well, awesome, I hear you saying. Now you've learned this radical number from this, special 18th century professor with 6 kids. Huh. But how is this useful? Well, just like most things in life, money, happiness, time, the mole is only useful for being converted to something else. Yes, after all, what's time if you don't convert it into meaningful achievements and productivity? What's happiness if you don't convert it into something you can share with others? And what's money if you don't convert it to meaningless in-game currency? Anyway, CSEC requires that you be able to convert between the mole, number of particles, and the mass of a given sample. Don't worry though, there's a lot more for you to learn with the moles in the syllabus, but those conversions will be what we cover in this video. If you look at the following diagram, you'll see a pretty comprehensive synopsis of everything we'll spend the rest of this video talking about. Of course, to tackle this, you only have to be familiar with division and multiplication. If you aren't, I'll kindly redirect you to the 2nd grade. Anyhow, many questions you'll encounter will follow a basic structure, like calculate the blank of some compound and some quantity of that compound, or how many blanks are there in some quantity of some compound. Let's start with a simple question. How many moles of nitric acid, HNO3, are present in 252 grams of nitric acid, just to clarify? All you have to do in this circumstance is calculate the molar mass of nitric acid and divide 252 by that value. The molar mass of a molecule is the same as the sum of the molar masses of all the elements it contains, which, as you probably remember, is the same as the relative atomic mass. So, nitric acid, formula HNO3, contains 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atoms. Adding their molar masses, 1 plus 14 plus 3 times 16, gives us 63 grams per mole, so each mole of nitric acid has a mass of 63 grams. When we divide 252 grams by 63 grams per mole, we get 4 moles. Easy, right? It's like finding the price of one big deal at KFC after dividing by the price you paid for 6 to make sure you haven't been scammed somehow. Don't worry though, you did that to yourself. Reversing this calculation, converting moles to mass, is just the reverse of the last one. Now, instead of dividing the given mass by the molar mass, we multiply the molar mass by the number of moles. For example, what's the mass of 0.4 moles of oxygen molecules? Well, all we have to do is find the molar mass of an oxygen molecule and multiply by 0.4. Hopefully you're already familiar with the fact that oxygen is a diatomic element. That is, it exists naturally as a molecule with 2 atoms. The molar mass of an oxygen molecule is 2 times 16, or 32 grams per mole. 0.4 moles times 32 grams per mole is 12.8 grams, giving us our answer. But what if you're asked to convert number of particles to or from moles? Lucky for us, we have the power of basic mathematical operations on our side. As we discussed before, 1 mole of any substance will contain 6.023 times 10 to the power of 23 particles of that substance. So, if you were asked to find the number of moles of magnesium, which contains 3.6138 times 10 to the power of 24 magnesium atoms, you would just have to divide by Avogadro's number, giving us 6 moles. The opposite is done when converting moles to number of particles. Simply multiply the number of moles by Avogadro's number. If you're good at transposition, then just remembering 3 equations can get you through basically any question. And if you're in a pinch, thinking through it logically will lead you to your answer. Let's check up on our friend from earlier. Way more than 2 minutes have passed at this point. You took the extra time to count your fingers and make sure they're all still here. Your parents will probably cut them off later. Here you are, handing in a blank test paper. Oh, wait, never mind. You did fill in your name, teaching you a valuable lesson. Don't be you. Wait. I think I worded that wrong. Don't let this be you. Much better. Future videos will cover more of Mole concept and how it relates to empirical and molecular formulae, as well as solutions, gases, and, wait for it, electrolysis. Be sure to visit qualper.com and check out the resources and say what you want to see next. Thanks for watching.